Our galaxy contains many billions of stars, and around many of them are systems of planets and moons. But for a long time, we didn't know much about galaxies. Just a century ago, we thought that the Milky Way was all there was. Scientists called it our island universe. For them, no other galaxies existed. Then, in 1924, astronomer Edwin Hubble changed all that. Hubble was observing the universe with the most advanced telescope at the time, the 100-inch Hooker on Mount Wilson near Los Angeles. Deep in the night sky, he saw fuzzy blobs of light that were far, far away. He realized they weren't individual stars at all. They were whole cities of stars, galaxies, way beyond the Milky Way.
Astronomers had an existential shock. In 1 year, we went from the universe being the Milky Way galaxy to a universe of billions of galaxies.
Hubble had made one of the greatest discoveries in the history of astronomy. The universe contains not just one, but a great number of galaxies. This is the Whirlpool Galaxy. It has 2 giant spiral arms and contains around 160 million stars. And Galaxy M87, a giant elliptical galaxy. It's one of the oldest in the universe, and the stars glow gold. And this is the Sombrero Galaxy. It has a huge glowing core with a ring of gas and dust all around it.
Galaxies are gorgeous. They represent, in some sense, the basic unit of the universe itself. They're like gigantic pinwheels twirling in outer space. It's like fireworks created by Mother Nature.
Galaxies are big, really, really big. On Earth, we measure distance in miles. In space, astronomers use light years. The distance light travels in a year. That's just under 6 trillion miles.
Here we are 25,000 light years away from the center of our galaxy, and our galaxy is over 100,000 light years across. But even that, as large as it is kind of a speck in the cosmic distance scale.
Our Milky Way galaxy may seem big to us, but compared to some others out there, it's actually pretty small. Andromeda, our nearest galactic neighbor, is over 200,000 light years across, twice the size of the Milky Way. M87 is the largest elliptical galaxy in our own cosmic backyard, and much bigger than Andromeda. But M87 is tiny compared to this giant. 6 million light years across, IC 1011 is the biggest galaxy ever found. It's 60 times larger than our Milky Way. We know galaxies are big, and they're everywhere. But why is that?
One of the very big questions we have in astrophysics is where galaxies come from. We really don't have a complete understanding of that. The universe started in what we call a Big Bang, an extremely hot, extremely dense phase, about 13.7 billion years ago. We know that nothing like a galaxy could have existed at that time. So galaxies must have been born. They must have formed out of that very early universe.
It takes gravity to make stars, and even more gravity to pull stars together into galaxies. The first stars formed just 200 million years after the Big Bang. Then, gravity pulled them together, building the first galaxies.
The Hubble Space Telescope has allowed us to peer back in time to almost the dawn of time, a period when galaxies have just begun to form.
The Hubble sees lots of galaxies, but the light we see today from those galaxies left there thousands, millions, even billions of years ago. It's taken all that time to reach us. So what we see today is the ancient history of those galaxies.
When we look at the Hubble Deep Field, what we see are little smudges. They don't look much like the galaxies we see today. They're just little smudges of light that we can barely discern. Those smudges of light contain millions or billions of stars that have just begun to merge together.
These faint smudges are the earliest galaxies of all. They were formed around 1 billion years after the beginning of the universe. But that's as far back as Hubble can see. If we want to go even further back in time, we need a different kind of telescope, one too big to launch into space. Well, now we have one in the high desert of northern Chile. This is ACT, the Atacama Cosmology Telescope. At 17,000 feet, it's the highest ground-based telescope in the world.
I really like working in the extreme environment of ACT. It's very, very cold often, and the wind blows violently. But the good thing about it from our point of view is that the sky is very, very clear almost all the time.
Clear skies are important for ACT's precise mirrors to focus on the earliest galaxies.
With ACT, we're able to zoom in with unprecedented detail on parts of the sky. We can also study the progress of growth of structures, where structures are things like galaxies and clusters of galaxies, with the very fine scale detail.
ACT doesn't detect visible light. It detects cosmic microwaves from the time the universe was just a few 100,000 years old. The telescope not only detects early galaxies, it actually sees how they grew.
We're able to track the progress of the formations of galaxies and clusters of galaxies. We see the footprints of all the galaxies that have grown in the time between when the universe was a few 100,000 years old till now.
ACT has helped astronomers understand how galaxies have evolved since almost the beginning of time itself.
And can start answering the question, what did galaxies look like when they were young? How do they compare with modern-day galaxies? How have they grown?
Astronomers are seeing how galaxies evolve from groups of stars into the patchwork of systems we see today.
Our current understanding is that stars form clusters that build into galaxies, that build into clusters of galaxies, that build into superclusters of galaxies, the largest structures we observe in the universe today.
Early galaxies were a mess, lumpy bunches of stars, gas, and dust. But today, galaxies look neat and orderly. So, how do messy galaxies transform into beautiful spirals and pinwheels? The answer is gravity. Gravity shapes galaxies and controls their future. There is an unimaginably powerful and incredibly destructive source of gravity at the heart of most galaxies. And there's one buried deep at the center of our own Milky Way. Galaxies have existed for over 12 billion years. We know these vast empires of stars come in all shapes and sizes, from swirling spirals to huge balls of stars. But there's still a lot about galaxies we don't know.
How did galaxies come to have the shapes they do? Was a spiral galaxy always a spiral galaxy? The answer is almost certainly no.
Very young galaxies are messy and chaotic, a jumble of stars, gas, and dust. Then, over billions of years, they evolve into neat, organized structures, like the Whirlpool Galaxy, or our own Milky Way.
Our Milky Way began not as a single baby galaxy, but many. What is now our Milky Way was once comprised of lots of small structures, irregularly shaped objects that began to merge.
The thing that pulls the small structures together is gravity. Gradually, it pulls stars inward. They begin spinning faster and faster and flatten into a disk. Stars and gas are swept into huge spiral arms. This process was repeated billions and billions of times across the universe. Each of these galaxies looks different, but they do have one thing in common. They all seem to orbit something at their center. For years, scientists wondered what could be powerful enough to change how a galaxy behaves. They found out: a black hole. And not just any kind of black hole, a supermassive black hole.
The first clue that supermassive black holes existed was that at the heart of some galaxies, there was an immense amount of energy emanating out from the center. What we're seeing is the black holes and these galaxies feasting on the material around them. So it's like having a huge Thanksgiving dinner.
The meal is gas and stars, and it's being eaten by the supermassive black hole. When black holes eat, they sometimes eat too fast and spit their dinner back out into space in beams of pure energy. It's called a quasar. When scientists see a quasar blasting from a galaxy, they know it has a supermassive black hole. But what about our galaxy? There's no quasar here. Does that mean there's no supermassive black hole? Andrea Ghez and her team have spent the last 15 years trying to find out.
So the key to discovering a supermassive black hole at the center of our Milky Way is to watch how the stars move. The stars move because of the gravity, just like the planets orbiting the sun.
But the stars closest to the center of the galaxy are hidden by clouds of dust. So Ghez used the giant Keck telescope in Hawaii to look through the clouds. What she saw was a strange and brutal place.
Everything is more extreme at the center of our galaxy. Things move really fast, and stars are going to be whizzing by one another. It's windy, it's violent, it's unlike any place else in our galaxy.
Ghez and her team began to take pictures of a few stars orbiting near the center.
The task has been to make a movie of the stars at the center. And so you have to be patient, because you take a picture and then you take another one and you see it move.
The pictures of the orbiting stars revealed something amazing. They were moving at several million miles an hour.
When we had the second picture was the most exciting point in this experiment, because it was clear to us that these stars were moving so fast that the supermassive black hole hypothesis had to be right.
And it was right. Ghez and her team tracked the movement of the stars and pinpointed what they were orbiting. There's only one thing powerful enough to sling big stars around like that: a supermassive black hole.
It's the gravity of the supermassive black hole that makes these stars orbit. So the curvature was the definitive proof of a supermassive black hole at the center of our galaxy.
The black hole at the center of the Milky Way is gigantic, 15 million miles across. So, is Earth in any danger?
We are in absolutely no danger of being sucked into our supermassive black hole. It's simply too far away.
In fact, the Earth is 25,000 light years away from the supermassive black hole at the center of the Milky Way. That's many trillions of miles. The Earth is safe, for now. Supermassive black holes may be the source of huge amounts of gravity, but they don't have enough power to hold galaxies together. In fact, according to the laws of physics, galaxies should fly apart. So why don't they? Because there's something out there even more powerful than a supermassive black hole. It can't be seen, and it's virtually impossible to detect. It's called dark matter, and it's everywhere. Astronomers have figured out that supermassive black holes live at the heart of galaxies and pull stars at incredible speeds. But they're not strong enough to hold all the stars in a gigantic galaxy together. So, what does hold them together? It was a mystery until a maverick scientist came up with the idea that something unknown was at work. Back in the 1930s, Swiss astronomer Fritz Zwicky wondered why galaxies stayed together in groups. By his calculations, they didn't generate enough gravity, so they should fly away from each other.
And so he said, well, I know that they haven't flown apart. I see them all gathered together in this nice collection. Therefore, something must be holding them in place. But our own gravity was just not strong enough. And so he concluded that it must be something which nobody had detected before, nobody had thought about, and he gave it this name, dark matter. And this was really a stroke of genius.
Fritz Zwicky was decades ahead of his time, and that's why he grated on the astronomical community. But you know, he was right.
If what Zwicky called dark matter held galaxies together in groups, perhaps it also holds individual galaxies together. To To find out, scientists built virtual galaxies in computers with virtual stars and virtual gravity.
We did a simulation where we put a lot of particles in orbit in a flat disk, which was just like the picture of our galaxy. And we expected to find that we get a perfectly good galaxy, and we were looking to see if it had a spiral or whatnot. But we found it always came apart.
There just wasn't enough gravity in the galaxy to hold it together. So, Oestreicher then added extra gravity from virtual dark matter.
It seemed like a natural thing to try, and it solved the problem. It fixed it.
Gravity from dark matter held the galaxy together.
Dark matter acts as a sort of protective scaffolding for galaxies that really holds them up and holds them in place and prevents them from falling apart.
Now, scientists are discovering that dark matter doesn't just hold galaxies together. It might have sparked them into life.
We think that dark matter was created out of the Big Bang, and dark matter began to clump. And these clumpings of dark matter eventually became the nuclei, the seeds for our galaxy.
But scientists still have no idea what dark matter actually is.
Dark matter is weird because we don't understand it at all. It's clearly not made of the same stuff that you and I are made of.
You can't push against it, you can't feel it, yet it's probably all around us. It's a ghost-like material that'll pass right through you as if you didn't exist at all.
We might not know much about dark matter, but the universe is full of it.
So the dark matter, weight for weight, makes up at least 6 times as much of the universe as does normal matter, the stuff that we're all made from. And without it, the universe just wouldn't work the way that it seems to work.
But the universe does work, so maybe dark matter is real. Strange stuff. And recently, it's been detected in deep space. Not directly, but by observing what it does to light. It bends it in a process called gravitational lensing.
Gravitational lensing really allows us to test the presence of dark matter. And the way that works is that as a beam of light from some distant galaxy is traveling towards us, if it passes by a large collection of dark matter, its path will be deflected around that dark matter by the gravitational pull.
When the Hubble telescope looks deep into the universe, some galaxies do seem distorted and stretched. That's caused by the dark matter, which warps the image. It's sort of like looking through a goldfish bowl.
By probing the shapes of those galaxies and the degree of distortion, we can really measure very accurately the amount of dark matter that's there.
It's clear now that dark matter is a vital ingredient of the universe. It's been working since the dawn of time and affects everything, everywhere. It triggers the birth of galaxies and keeps them from falling apart. We can't see it or detect it, but nevertheless, dark matter is the master of the universe. Galaxies look isolated. It's true, they are trillions of miles apart. But actually, they live in groups called clusters. And these clusters of galaxies are linked together in superclusters containing tens of thousands of galaxies. So, where does our Milky Way galaxy fit in?
If you take a look at the big picture, you realize that our galaxy is part of a local group of galaxies, perhaps 30, and our galaxy and Andromeda are the 2 biggest galaxies in this local group. But if you look even farther out, we are part of the Virgo supercluster of galaxies.
Scientists are now mapping the overall structure of the universe and the position of clusters and superclusters of galaxies. This is Apache Point Observatory in New Mexico, home to the Sloan Digital Sky Survey, or SDSS. It's a small telescope with a big price tag, and it has a unique mission. SDSS is building the first 3D map of the night sky, a process that's identifying the exact positions of tens of millions of galaxies. To do it, SDSS goes galaxy hunting way out into space, far beyond our Milky Way. It pinpoints the positions of galaxies, and this information is copied onto aluminum discs.
These aluminum discs are about 30 inches across, and they have 640 holes each. And these holes correspond to the objects of interest in the sky.
Each object is a galaxy. Light from the galaxy is channeled through a hole and down a fiber optic cable. This method records data on distance and position from thousands of galaxies and plots their location in 3D.
It's telling us about their shape, it's telling us about their makeup, it's telling us how they're distributed, and all of this is very important to astronomy in understanding our universe.
And this is what they're creating, the biggest 3D map ever. The map is showing us things we've never seen before. It shows galaxies in clusters and superclusters. But pull back even more, and we see that these superclusters are connected into structures called filaments. SDSS has found one that's 1.4 billion light years across. It's called the Great Sloan Wall, and it's the largest single structure ever discovered in the history of science.
You get a sense of that you are in something quite vast. You could see the clusters and filaments as the data would scroll by. And you know, each one of these little fuzzy spots were actually galaxies, not stars, but galaxies. And so you're seeing whole clusters of these things.
SDSS is showing galactic geography on a vast scale. Scientists have taken it even further. They've built the whole universe in a supercomputer. Here, you can't see individual galaxies. You can't even see galaxy clusters. What you can see are superclusters linked together on filaments in a vast cosmic web.
As one begins to come back from the whole scale of the universe, one begins to reveal a filamentary pattern, a cosmic web containing galaxies and clusters of galaxies that light up the universe, where there are as many galaxies in that direction as that direction as that direction as that direction. And in fact, on larger scales, the universe kind of looks like a sponge.
Each of the filaments is home to millions of galaxy clusters, all bound together by dark matter. In this computer simulation, the dark matter glows along the filaments.
Dark matter affects where in the universe galaxies will form. When we look at galaxies, they're not sprinkled around at random. They actually tend to form in little groups, and that's really reflecting the large-scale distribution of dark matter.
Dark matter is the glue holding together the whole superstructure of the universe. It binds galaxies in clusters and clusters in superclusters. All these are locked together in a web of filaments. Without dark matter, the whole structure of the universe would simply fall apart. This is the big picture of our universe. It's a giant cosmic web. And hidden deep in one of these filaments is the Milky Way. It's been around for nearly 12 billion years. But in the future, it's going to be destroyed in a gigantic cosmic collision. Galaxies are vast kingdoms of stars. Some are giant balls, and others complex spirals. Thing is, they never stop changing.
While it may seem when we look out at our galaxy that our galaxy is static and been here forever, it's not. Our galaxy is a dynamic place. Its very nature has been changing over cosmic time.
Galaxies not only change, they move as well. And sometimes they run into each other. And when they do, it's eat or be eaten.
There's a zoo of galaxies that you can find out there, and this entire zoo can interact or collide with any of the other members of the zoo.
This is NGC 2207. It looks like an enormous double spiral galaxy, but it's actually two galaxies colliding. The collision will last millions of years, and eventually the two galaxies will become one. Collisions like this happen all over the universe. Our own Milky Way is no exception.
The Milky Way is, in fact, a cannibal. And it exists in its present form by having cannibalized small galaxies that it literally ate up. And today we can see small streams of stars that are left over from the most recent mergers that have formed the Milky Way galaxy.
But that's nothing compared to what's coming up. We are on a collision course with the galaxy Andromeda. And for the Milky Way, that's bad news.
Our Milky Way galaxy is approaching Andromeda at the rate of about 250,000 miles per hour, which means that in 5 to 6 billion years, it's all over for the Milky Way galaxy.
You would see the entire Andromeda galaxy speeding towards us, really barreling straight into us. As the two galaxies interact, they both become more and more disturbed and closer together, and the whole process starts to snowball.
The two galaxies will enter a death dance.
This is a simulation of the future collision, sped up millions of times. As the galaxies crash together, clouds of gas and dust are thrown out in all directions. Gravity from the merging galaxies rips stars from their orbits and shoots them deep into space.
As we approach doomsday for the Milky Way galaxy, it would be spectacular. We would have a front row seat on the destruction of our own galaxy. Eventually, the two galaxies will go right through each other and then come back and then coalesce.
It's strange, but the stars themselves won't collide. They're still too far apart.
All of the stars are basically just going to pass right by each other. The probability of one individual star hitting another individual star are basically zero.
However, the gas and dust between the stars will start to heat up. Eventually, it ignites, and the clashing galaxies will glow white hot.
So at a certain point, the sky could be on fire.
The Milky Way and Andromeda as we know it will cease to exist, and Milkomeda will be born, and it will look like a whole new galaxy.
This new galaxy, Milkomeda, will become a huge elliptical galaxy without any arms or spiral shape. There's no escaping what's going to happen. The question is, what's it mean for planet Earth?
We may either be thrown out into outer space when the arms of the Milky Way galaxy are ripped apart, or we could wind up in the stomach of this new galaxy.
Stars and planets will be pushed all over the place. So this may well be the end of planet Earth. Galaxies all over the universe will continue to collide. But this age of galactic cannibalism will eventually pass. Because there is an even more destructive force in the universe, a force that nothing can stop. It will ultimately push galaxies away from each other, stretching everything until the universe rips itself apart. Galaxies are home to stars, solar systems, planets, and moons. Everything that's important happens in galaxies.
Galaxies are the lifeblood of the universe. We arose because we live in a galaxy. And everything we can see and everything that matters to us in the universe happens within galaxies.
But the truth is, galaxies are delicate structures held together by dark matter. Now, scientists have found another force at work in the universe. It's called dark energy. Dark energy has the opposite effect of dark matter. Instead of binding galaxies together, it pushes them apart.
The dark energy, which we've only discovered in the last decade, which is the dominant stuff in the universe, is far more mysterious. We don't have the slightest idea why it's there.
What it's made from, we don't really know. We know it's there, but we don't really know what it is or what it's doing.
Dark energy is really weird. It's as if space has little springs in it, which are causing things to repel each other and push them apart.
Far in the future, scientists think that dark energy will win the cosmic battle with dark matter. And that victory will start to drive galaxies apart.
Dark energy is going to kill galaxies off. It's going to do that by causing all the galaxies to recede further and further away from us until they're invisible, until they're moving away from us faster than the speed of light. So the rest of the universe will literally disappear before our very eyes. Not today, not tomorrow, but in perhaps 1 trillion years, the rest of the universe will have disappeared.
Galaxies will become lonely outposts in deep space. But that's not going to happen for a very, very long time. For now, the universe is thriving, and galaxies are creating the right conditions for life to exist.
Without galaxies, I wouldn't be here, you wouldn't be here, perhaps life itself wouldn't be here.
We're lucky. Life has only evolved on Earth because our tiny solar system was born in the right part of the galaxy. If we were any closer to the center, well, we wouldn't be here.
At the center of a galaxy, life can be extremely violent. And in fact, if our solar system were closer to the center of our galaxy, it'd be so radioactive that we couldn't exist at all.
Too far away from the center would be just as bad. Out there aren't as many stars. We might not exist at all.
So in some sense, we are in the Goldilocks zone of the galaxy. Not too close, not too far, but just right.
Scientists believe that this galactic Goldilocks zone might contain millions of stars. So, there may be other solar systems that can support life right here in our own galaxy. And if our galaxy has a habitable zone, then other galaxies could too.
The universe is immense, and the amazing thing is that we're always discovering more.
Every time we think we know the answer to one problem, we find it's embedded in a much bigger problem. And that's exciting.
There are endless questions to ask and mysteries to solve. In our own galaxy, the Milky Way, and in galaxies all across the universe.
10 years ago, who would have thought that we'd be able to identify the black hole at the center? Who would have thought 10 years ago that the astronomical community would believe in dark matter and dark energy?
More and more, scientific research is focusing on galaxies.